Hi, my name is Sean Fournier, product specialist for dryspin lead screws at igus. And today, we're going to be discussing how to use our online custom lead screw configurator. Let's hop right in. So the first thing we're going to do is go to the igus.com homepage. From there, we'll click on the Configurator tab here at the top of the screen. Once it loads, we'll go to the linear motion technology bubble and scroll down to the lead screw section. Once here, you'll see our custom lead screw configurator. This is an excellent resource for designing custom journals on lead screws. The first thing we like to go through is to choose our unit of measure. You can choose between metric or imperial. In addition to that, you should always click on the configuration tab here and click new configuration. This ensures that anything that was configured previously is cleared from the cache. From there, you select your screw geometry. We have trapezoidal thread, high helix, metric or all thread, Acme threaded rod as well. Today, we'll select high helix thread dryspin technology. From here, we'll select our specific screw size. And keep in mind, these screws are broken down by diameter and lead, or distance of travel per rotation. Today, we'll look at a dryspin 12 by 25. From there, this screw comes in a few different options. So we have right hand, left hand, as well as reverse thread, which is one screw with left and right thread on it. From here, we'll do our material selection. Dryspin only comes in stainless steel, although we do have some screws that come in aluminum as well as carbon steel. From there, we will select our quantity, which will be 1 for today. And then we start designing. The first thing we enter here is the length of the screw from end to end. And that'll be 500 millimeters in this case. On to the next page. This is where we start designing the actual machined ends. You can machine on both sides of the screw if you'd like. And then from there, we start designing. And keep in mind, as you design more and more stages, we are working from the end in. This is one of the most common mistakes I see people make using this tool. So for a machined end, the first section we'd like to do, 8 millimeter diameter. Select our tolerance range, and then the length of that machined end, which we'll leave at 10 millimeters. You can add more sections in as well to have multiple steps. So for this section, we'll do 10 millimeters. And you notice here that no tolerance range is given, because it does give the disclaimer that there will be some remaining thread on this section here. And finally, the length of that we'll leave at 10 millimeters. Now, we can do step downs and journals. We can also do a much larger array of custom options. We can do everything from bevels to threaded ends to internal threads, as well as keyways and flats. Today, we'll look at a spanner flat and how to drag and drop these. So it's as simple as taking it and dragging it to the section you'd like it installed with. You'll be greeted by this screen where you can configure how deep, how far in your flat will be. So for this one in particular, we'll be looking at 4 millimeters from end to beginning, 5 millimeters length of the flat, and then finally, SW, we will go with 6. And the SW is the width of the actual flat itself, the density at its thickest point. Apply that section to it. From here, you can select your tolerance ranges. You can offer our standard offerings as well as more precision tolerances as well. Today, we'll stick with the standard. And just like that, we've generated our custom screw ready with pricing to order. In addition to that, you can also download a PDF document breaking down the details of the screw, as well as a dimension drawing. And this dimension drawing is very, very useful and helpful. You can have it downloaded in both metric as well as imperial dimensions. And that drawing will look something like this. One of the best parts of this tool is that we can actually copy this drawing number and add it back into the tool for future configuration using the DSK ID section here. It'll reconfigure your screw for any future purchases, or maybe you're just not ready to buy at the time of designing, and you want to come back and not have to do this all again. Overall, this tool is a great resource for any engineers looking to design a custom lead screw, whatever that may be. For more resources or to learn anything else about dry spin lead screws, click the link below.